Stop letting state management cripple your large Flutter applications. When widgets are deeply nested, prop drilling becomes inevitable, leading to excessive, unnecessary widget rebuilds across the entire tree. Centralized state management solves this by strictly decoupling business logic from the user interface layer, drastically improving maintainability. Redux enforces a strict unidirectional data flow using a single immutable store. Every state change requires explicitly dispatching an action. In contrast, MobX uses reactive programming built on observable data structures. MobX allows direct state mutation, but only within defined actions. The choice hinges on your team's preference. Redux provides structural rigidity and guaranteed immutability, while MobX offers flexibility and reactivity. We will implement both solutions step by step. To begin Redux implementation, install the Redux and Flutter Redux packages. Define the application state as a single immutable class. Using packages like freezed or built value guarantees this immutability, preventing accidental state corruption. The core store object is instantiated by providing the root reducer function and the initial state object. Actions are simple classes that describe the intended state transition. We often use sealed classes for actions to carry necessary payloads efficiently. The reducer function is the only place where state changes occur. It accepts the current state and the dispatched action, then returns a brand new state instance. Crucially, the reducer must be a pure synchronous function, meaning it cannot contain any side effects, such as network calls or database access. Asynchronous operations, including network requests or local database access, are strictly forbidden within reducers because reducers must remain pure functions. Middleware intercepts dispatched actions before they ever reach the reducer function. The Redux Thunk package is the standard solution for managing asynchronous logic in Redux. A thunk is a function that is dispatched to the store instead of a standard action. This thunk function receives both the dispatch function and the getState function as arguments. The thunk executes the asynchronous operation, and upon completion, it dispatches subsequent success or failure actions to update the state. Middleware functions are passed as a list directly into the store constructor during the application initialization phase. The Store Provider widget must wrap the application root, injecting the Redux store instance into the Flutter widget tree context. User interface widgets consume specific state slices using the generic StoreConnector state app slice. The VMware is a local class defined specifically for that widget, responsible for holding the required state data and the necessary dispatch functions. The converter function inside the StoreConnector performs the crucial mapping from the global app state to the local VMware. This explicit mapping is essential because it ensures the widget only rebuilds when the specific map state slice changes, preventing unnecessary updates. Actions are invoked by calling the dispatch function exposed through the VMware instance. MobX state management is fundamentally built upon three core concepts: observables, actions, and reactions. Observables are standard class fields annotated with the @observable decorator, representing the mutable state data that MobX tracks. Actions are methods annotated with @action that strictly define how those observables are mutated. Reactions are automatic side effects that are triggered whenever an observed state changes. Implementing MobX requires code generation using the MobX CodeGen and Build Runner packages. Running the command flutterpub run build generates the necessary reactive boilerplate code within the corresponding .g files, creating the functional store implementation classes. Define the MobX store class by extending the base store class and including the generated mixin, typically named _.storename. Computed values represent derived state and are annotated with @computed. These values automatically cache their results and only reevaluate when their underlying dependent observables change. Reactions, such as auto-run or win, manage side effects that operate outside the user interface layer. Auto-run executes immediately upon definition and automatically tracks any accessed observables, running again whenever those dependencies change. For asynchronous state mutations, use the async action annotation. This ensures that all state modifications occur strictly within the action boundary, maintaining state consistency and preventing race conditions. The standard provider package is typically used to inject MobX store instances into the Flutter widget tree context. The Observer widget is essential. It wraps any user interface components that rely on observable state. The observer automatically subscribes to every observable accessed within its build method. When an observer changes, only that specific observer widget rebuilds, drastically minimizing the scope of user interface updates. Accessing observables outside the observer's build method prevents automatic reaction tracking. This failure to track dependencies can lead to missed user interface updates or potential memory leaks if subscriptions are not manually disposed. Redux testing focuses primarily on unit testing the pure reducers, which simplifies test setup significantly. Middleware logic is tested in isolation, verifying action flow. MobX testing involves mocking the store instance and verifying that defined actions are called and that observables change as expected. Redux enforces a strict, predictable structure, which is highly advantageous for large development teams managing complex state machines. MobX offers greater flexibility and generates less boilerplate code for localized state, but requires careful management of side effects. Both Redux and MobX solutions have a negligible impact on the final application bundle size during deployment.